Hello. In this video, we're going to be using tables of outcomes, two-way tables, to calculate probabilities, as shown in the syllabus here. And these are the formulas shown in the formula booklet. A two-way table is a convenient way of illustrating information. A two-way table is a convenient way of showing information. In the example below, the two-way table shows the different modes of transport of a group of teachers to school. As shown here, 13 female teachers catch the bus to school. In order to use a two-way table to calculate probabilities, we first need to find the totals of all the rows and the columns. For example, how many teachers came by car in total, how many came by bicycle, how many came by bus, how many male teachers are there, how many female teachers are there, and in fact, how many teachers are there overall. So adding the columns, you can see that there are 67 teachers that came to school by car, 15 that came by bicycle, 23 that came by bus. And looking at the rows, you can see there are 57 male teachers and 48 female teachers. And looking at this bottom right hand corner here, the grand total, we can see that altogether there are 105 teachers. In this question, we are asked to use the table to estimate various probabilities. So one of the first things to do is to extend the table to include all the rows. So the first thing to do would be to work out the totals of all the rows and all the columns. You can see the totals displayed here, and in fact there are 130 people. To estimate the probability that a randomly selected person from this group liked the ride, we need to identify how many that is. So looking at the table, we can see that there are 83 that liked the ride out of a total of 130. So the probability is 0.638. To estimate the probability that a randomly selected person from the group is a child and disliked the ride, you can see that there are 17 children out of 130 that disliked the ride. So the probability is 17 out of 130, or 0.131. And in part C, the probability that the person selected was an adult or someone that disliked the ride. What we can't do is simply add up the adults, 58, and people that dislike the ride, because that will include this number 30 twice. So what we have to do is add up the adults and then the people that dislike the rides as an extra 17, okay, and that's our number there. So the probability is 75 out of 130. In this question, a tourist is picked at random from the surveyed group, and we have to determine what age group the tourist is most likely to belong to. So we can start by adding totals to all the rows. And we can see now that there were 1,330 tourists, and the most likely age group was the 31 to 50, as there were 529 in that age group. So the tourist is most likely to belong to the 31 to 50 age group. So the probability that the tourist belongs to that age group will simply be 529 out of 1,330. And that's equal to 0.398. In part C, we're asked to see if the town has enough hotel capacity to meet the demand of 5,000 tourists. So if we next add totals to the columns, So the number of tourists who chose a hotel from this survey group was 370. So the probability of picking a person from the group to have used the hotels would have been 370 out of 1,330, and then we can use that probability to work out the expected number. So the expected number is approximately 4,451 tourists who use hotels. So on that basis, the town has sufficient capacity. In this question, the table gives us the results of a study into smoking behaviour of high school students. We're given the totals of most of the categories, and we have to work out the values of P, Q, and R. To work out the value of P, we simply just need to subtract 169 male smokers from the total number of males to find the non-male smokers. And that's equal to 245. To find the value of Q, we need to subtract that number, 245, non-male smokers, from the total number of non-smokers, 454, and that will give us Q. So Q is equal to 209. And to find the value of R, which is the total number of females, we need to add 145 to 209. And that's equal to 354. So now we can use the two-way table to calculate some probabilities. So if a student is selected at random in the study, what is the probability of selecting a female? Well, there are 354 females, 768 students. So the required probability is 354 over 768, 0.641. To calculate the probability of selecting a male non-smoker, we identify that there are 169. So the probability will be 169 over 768, which is equal to 0.220. In part D, the probability of selecting a non-smoker, we identify that there are 454 non-smokers. So the probability is 454 over 768, and that's equal to 0.591. In this question, the table shows the results of an experiment into the study into the phenomenon of colour blindness. Again, the totals are already given, so we can go straight ahead and calculate the probabilities. There are 42 colour blind individuals, and there are 1,000 people surveyed, so the probability is 42 over 1,000, 0.042. In part B, the probability of selecting a colour-blinded female, well, there are 2 colour-blind females, and so the probability is 2 over 1,000, 0.002. Now in part C, we're told that the person being selected is known to be a female. So that reduces the sample space down from the original 1,000 down to 490, as there are 490 females. So out of those 490 females, again, 2 of them are colourblind, so the probability is 2 out of 490. Or 0.004. In this last question, the table shows different types of books and different sizes of those books, with a number of pages. So before we can calculate probabilities, we need to add totals to each row and column. adding the rows first, and then adding the columns, we see that there are 80 books. To find the probability that a randomly selected book is a fiction book, we see that there are 59 fiction books out of the 80, shown in red here. So the probability is 59/80ths. Now in part B we're told Alicia randomly selects a non-fiction book. So again, that reduces the sample space down from 80 to 21. Okay, I call that the reduced sample space. So given that Alicia has selected a non-fiction book, what is the probability that it had under 200 pages? Well, we can see, shown in blue, that there were 3 non-fiction books out of the 21 that had under 200 pages. So the probability is 3 out of 21, which is equal to 1/7.